solving polynomial equations. So depending on the equation we're given, it can be easy or difficult to solve polynomials. So let's have a look at a simple one where it's already factorized for us. So x minus 5, x plus 3, and x minus 1 all equals 0. So solving this, we can solve just like how we would a quadratic with only two terms, where if we have three things being multiplied by each other and they're equaling 0, that either one of them has to be 0, or two of them can be 0, or all three can be 0. So all we do here is just solve each factor if it was equal to 0. So we get three equations. Adding 5 to both sides gives us x equals 5. Minusing 3 from both sides gives us x equals minus 3. And adding 1 to both sides gives us x equals 1. I personally like writing them in ascending order. So we have minus 3, 1 and 5 as our solutions for x for that one. So when the coefficient of x is not 1, so in all these ones the coefficient of x was 1, so it was pretty simple. We could actually just grab all of these constant terms and just change their signs. So plus 3 became minus 3, minus 1 became 1, and minus 5 became 5. But when the coefficient of x is not 1, we just have to be slightly more careful. So let's look at 5x plus 1, 3x minus 8, and x plus 10 equals 0. So solving each one of these factors for 0 is going to give us our solutions to this polynomial. So here we can minus 1 from both sides, then divide both sides by 5, so we get minus a fifth. Here we can add 8 to both sides, then divide both sides by 3, and here we can just subtract 10 from both sides. So this is going to give us x equals minus 10, minus a fifth, and 8/3 as our solution. What if the polynomial is not factorized? So let's look at x cubed plus 2x squared minus 5x minus 6 equals 0. So to solve this, we can actually use the factor theorem. We can use the factor theorem to get our solutions. Because if we sub in a value for x and we get it equal to 0, we know it's a solution. So we could let p of x equal our polynomial. So p of x equals x cubed plus 2x squared minus 5x minus 6. And we know if we sub in p of a and it equals 0, then x minus a is a factor, which also means a is a solution. And remember, the factors we want to try are the factors of the constant term. So in this case, our constant term is minus 6. So factors we'd like to try will be plus or minus 1, plus or minus 2, plus or minus 3, or plus or minus 6. And potentially 3, because we have a cubic polynomial, so there should technically be 3 solutions. So we could go ahead and sub in some values. So we can try 1 first. So we'll get 1 cubed plus 2 times 1 squared minus 5 times 1 minus 6. And this does not equal 0 if you solve it. So it's not one we're interested in. You can try minus 1. We get minus 1 cubed plus 2 times minus 1 squared minus 5 times minus 1 minus 6. This one does equal 0. So we know that therefore x has to, if x is minus 1, that'll be a solution to the polynomial. Which also means that x plus 1 is a factor. So again, you could you have a couple of options here. You could keep trying these other numbers and keep going until you get them equaling 0. Or you can do long division with x plus 1 and get a quadratic equation. So get a quadratic as your solution and then just factorize that to get your solutions. So if you did the long division of our polynomial x cubed plus 2x squared minus 5x minus 6 with x plus 1, our factor, I'm not going to go through it, but you would get a remainder of 0, and you'd get x squared plus x minus 6 as your quadratic, which means our polynomial could be written as x plus 1 outside of x squared plus 6 plus x minus 6, and we can factorize that quadratic. So looking for two factors that multiply to negative 6 and add up to 1. So we should get plus 3 and minus 2, which means we can easily find our solutions for x being minus 3, minus 1, and 2.